What is virtual commissioning? Because up to now I talked about simulation. Virtual commissioning, as we define it, people have different interpretations of this, but virtual commissioning for us is validating your automation code against a physical or kinematic system or a robot system. And there's three parts to that. There's the automation part, like if you open up that electrical cabinet on any machine, you've got a PLC in there, perfect. He's the brains. And we can do real or virtual for the automation. But that middle portion, the electrical model, this is where a lot of other companies, maybe Siemens, can really differentiate in this space, because what else is in that electrical control cabinet? It's more than just a PLC. Big one is drives. And what happens if you've got safety on drives or some specialty I/O that need to communicate to the PLC, but they have their own behavior model? So Siemens, we can support you there as well for the electrical simulation. It's a kind of a deeper, more granular level of simulation. And then the model, well, the model depends on your use case. Are you doing detailed physics for kinematics on a machine if you're a machine builder? Are you a line builder, a line integrator, and it's robotics lines? Or you're the end user, the manufacturer, and I've got a different use case there. So those are things Siemens can help you as far as you get into this. And this next, so that's kind of just a visualization of what we have from our real or virtual PLCs on the automation model. Electrical, here you see the drives, and drives are that 800-pound gorilla in the corner, because the whole goal with simulation or virtual commissioning is whatever you develop on your PLC code or your drive logic to control the automation, the moment that starts to deviate from what you did virtually 6 months or whatever before that machine is built, the moment that deviation happens, the less the controls engineers will actually trust that when they actually use it. So you need to be able to consider both the automation aspect of it and the electrical behavior and drives and safety and all RFID cameras and all these different things have to be able to simulate it for the full system to be able to work well. And then in this scenario here, we're going to get into robotic simulation. So very quick before I pass it over to Teng, where he's really going to get into some insights for key use cases they found, is here we have our Tecnomatix Process Simulate on the left-hand side. This is robotic, battery assembly. And on the right-hand side, we have our virtual HMI, where you see our graph editor, where we can look at we can step through the code on the virtual HMI and really see where is the sequence of the machine. And here you see PLC logic driving the simulation with multiple robots, an ABB robot, a KUKA robot, or a FANUC robot, all working well together. And I can debug that logic and prove out that entire cell. And that's what I'm going to pass over now to Teng to get into. I don't want to lose sight of time, because we've got some good things we want to show you here today, these specific use cases. But the robot vendor is controlling the robot arm, but that robot does not live in isolation. Everything around that is going to be controlled by a PLC, or the safety, the guarding, the motion, and that's where we can actually really help simulate. Here you see example, we're going to poke the I/O signals for the safety, PLC code on the right side, modeling software on the left. So with that, Teng is going to take it over and go a couple of levels deeper on what they've seen in working with customers doing this.